Okay. So we studied about frequency distribution table and histogram, right? And today we will learn about several other types of graphs other than the histogram. Okay. So first type of graph is dot plot. So this dot plot is used for quantitative data. This is mainly used only to plot quantitative data. Okay, not qualitative but only quantitative data. So what is quantitative data? A data which consists of numbers. Exactly. So that is called as quantitative data, and qualitative in the sense the data which consists of letters or labels or categories. So these type of data comes under qualitative. And dot plot is a graph which is used to plot only quantitative data. Okay, I'll tell you why it is only quantitative and not qualitative. Now, as you can see here, this is a picture of example of a dot plot where this is like your class intervals, the horizontal line values, and the dots here are your frequency number. So what does 40 say? For example, if we are doing a dot plot for students who scored the grades of 40, 50, 60, 70, if we assume that this is like a grade, now how many students got 40 grade? It is only one. Okay, it is only one. How many got 50? It is 1, 2. And this is how we count the frequency numbers. Got it? So this is your dot plot. Now, where do we use this? So applications is in many fields. It can be in business, stock market, or even in financial, etc. Now, what is the purpose of dot plot? The thing is, this dot plot is very good at highlighting the gaps or outliers. So what is outliers? It's a data or it's a value which lies in a very outer region or which lies very far away from other sample data values. That is called as outliers. So this dot plot is very helpful in highlighting those gaps and outliers. Okay, for example, if you have seen in the treadmill, you will see the minutes, right? So that is in the form of dots and it creates a pattern. So that is an example of a dot plot. Now, what is the limitation of this dot plot? This is used only for a scale of small to medium data values. You cannot use this for large data set. Why? Because it's hard to count, it's tedious a task, and it gets too cluttered when we have a very large data set. It's hard to find the frequency number. And that's why this is not good for large size data. Okay. Now, what are the disadvantages? As I said, we cannot construct this for large data sets. And what are the advantages? One advantage is that it shows the true values in the set. So what do I mean by true value? So if you have observed the frequency distribution table, whatever we have was the class interval. So it was like 2 to 4 or 5 to 6, something like that. We did not have the exact number, right? Now, if you see the dot plot, we have an exact number here. That is called as true value. So dot plots are used, or one advantage is that we can always construct using the true value. Okay? Now, answer this. What is the frequency number of data value 50? Yes, it is 2. What about 110? 0. And what about 100? 0. So this is how we count the frequency number for the dot plot. So as you can see here, if I ask you what is the dot plot or the frequency number of 71 here, this line after 70, it's hard to count the numbers. So that's the main disadvantage of this plot. Okay. So next plot is the, okay, so this one is, I told you that it is used only for quantitative and not for qualitative. Why? Because qualitative is nothing like more of a names or a label. Now, if I tell you to construct a graph between a city name and sex, females and males, it's hard. I mean, you cannot plot, right? Because it's more often names. You cannot relate them using a graph. You can relate them only using numbers. Okay, so and that is why we don't use these plots for qualitative. Next is stem plot. This is also used for quantitative data. Now here it is constructed in such a way that we will have two parts in this graph: stem and leaf. Stem and leaf. So the first number, whichever you write here, is called as stem, and the next number is called as leaf. Now, how do you write this number? For example, if your pulse rate is 40, the first number will always be in the stem, and the second number will be in the leaf. Okay? So, for example, now I have a number 40 and 45. Okay, and then have 42 and 44. So how do we construct stem and leaf for this? The first value, whichever you write, should be in the stem, and the next number should be in the leaf. 40. So every number starts with 4. Okay, so I will write 4 here, and this is my first value, 40, where first number belongs to stem, second number will always be in the leaf. And it has to be in the order, highest, lowest to highest. So second number, we will go for 42 because this is after 40. So we already have wrote the first number, we don't have to write it again. What is my next number is 2, which is in the leaf. Likewise, the third value is 45, 4 is already there. We have to write this 5 in the leaf section. 4 and 5. This is my third value, this is my fourth value. Okay, now what if I have something like this? 45, 55, say 66, 78. How do you construct stem and leaf for this? Stem and leaf. This is my first number. So what is the stem? 4. Leaf. Next number. Exactly. And 8. Right? So it goes on like this. You have to write in the next value or next line if you have a different digits. So this is how you create stem and leaf. Usually you will have two numbers. If you have three numbers, then you will write the starting two digits in the stem and the remaining will be in the leaf. Now, what are the uses? This stem and leaf is used to classify the data, like it can be classified among discrete or continuous, and it also shows us how the data is spread out, how far is the data. That is one use. And advantage is data are all grouped, and also you can see that it has original data or the true values which we discussed in the dot plot. Okay. Now what is the difference between dot plot and stem plot? Because dot plot also uses the true value, and stem plot also uses the true value. The main difference is that this in this stem plot we have a data arranged in an order. It will be like highest to lowest to highest. Okay? In stem plot, the data values will always be in an order. Fine? And disadvantages, again the same thing. We only use this plot for small data set. We cannot keep on writing this for a large number of data sets. So that's the main disadvantage. Now here, as you can see, this is one of the example. Now you have to answer this question. This is the student scores on the quiz. It's like 0, 3, which means 3, 0, 6, 6, and 0, 5 is number 5. Fine? And this is like 10, 11, 14, 13, 15, 15. Now answer this question. Which is the most common score in this table? Yes, it is 20. Now, Alia, answer this question. What is the highest score? You have to unmute.
I'm sorry, can you repeat that?
What is the highest score in this table?
The highest score is 20.
Good. And Ashley, what is the lowest score?
Is it 3?
Yes. So if you see, it is very easy to observe the data and answer these questions, right? So that's one of the advantage of stem and leaf. But you cannot construct this for large data set, and that is the disadvantage. Now, how do you construct stem and leaf for decimal numbers? So I told you, if there are 3 digits, what do? You keep the first 2 digits in the stem and you write the remaining digits in the leaf, right? What will you do if you have decimals? Or do you think the stem and leaf looks like? Yeah. So it is similar to 3 dots. So it'll be like this. This is your stem and this is your leaf. If you have a value 56.3, you will be writing the first 2 values here and the remaining values here. Now you can ask me that if we have a table, if I give you a table and tell you and ask you that whether these values are decimals or not, how do you say? Because this is how we construct for 3 digits. Suppose if you have 3 digits, 563, how do you construct this? It will be same thing, 56 and 3, right? Now what is the difference? Well, when you construct stem and leaf, you have to observe the context. So if they're talking about, say, pounds of meat, you cannot have 563 pounds of meat. You cannot buy that much amount, right? Then it has to be a decimal, right? So that is how you differentiate. For example, the weights of students, weight of a person, it can't be 563, it can be 56.3. So this is how you have to observe and answer the questions. So in stem and leaf, the context plays an important role. Okay? Next graph is time series graph. In simple words, if I want to say, it is nothing but a value against time. you will have a graph where you will have to draw the time and you have to plot the data values against the time. Fine. Again, this is for quantitative data. Now, what are the applications? It is mostly used in economics, mainly in stock markets, and even in sales. So, one advantage is that this also identifies the gaps, outliers, and main advantage, which differentiates this with the other two graphs, is that it compares two subjects. So, how does the time graph look like? Like this. Now, we already have a line here which is telling you about the year and law enforcement fatalities. I can also have another line which tells about number of deaths and an year. I can have one more line which can tell about number of COVID cases and year. So you can have multiple lines. So you can easily compare the data in the time series graph. That's the main advantage. And disadvantage is that if you want to construct this graph for an extended time period, that will not be a good idea. So you cannot have the same graph constructed over a extended time period. And the data here which you construct may not be accurate always. So that is the main disadvantages. Next is the bar graph. This is also used, okay, so this is the highlight here. This is used for categorical data, okay, which is qualitative. So the graphs which we saw till now is for quantitative and this is for qualitative data. Bar graph is for qualitative data. So advantage is that it is easy to understand the information. Disadvantage is that it is unable to show some patterns or the effects which happens over the time. So that's the main disadvantage of the bar graph. And one more advantage is that it is easier to compare with different categories and it shows the relative distribution of categorical data. So this is how the bar graph looks like. Now you can also construct this using the frequency number and you can also construct the bar graph using percentile. That is the relative frequency distribution, right? Relative frequency distribution is nothing but it's a part of the frequency distribution which is expressed in percentage. Okay, so this is your bar graph. Applications, again, it is most commonly used in sales and financial. Next is your Pareto chart, which is also a bar graph. It's type one of the type of bar graph. Here, the only difference is that it is arranged in an order. So your graph looks like decrease in the height from highest to lowest. So this is how it looks like. So if you have a bar graph and it is decreasing in this way, then that is called as Pareto chart. So advantages, disadvantages, uses will be same as the bar graph. Only difference is in the decrease, the pattern. Pie chart. So one example I can give you is pizza, and you will have some like 8 slices, and you can imagine having different toppings on each slices. So that is an example of your pie chart. Or you can have a spin wheel with number of divisions, right? With a circle, number of divisions, that is example of your pie chart, and this is how it looks like. So most oftenly, your pie chart will be expressed in percentage. And always the total number, if you are expressing this in percentage, the total number should be 100%. So if you count 60 plus 30 plus 5 plus 3 plus 2, it will give you 100 percentage. It has to be 100. One advantage is that you can display multiple classes of data in one chart. Okay, for example, let's see this. So here they're expressing blood type and the frequency number. Okay, so they are constructing bar graph for only one variable, that is blood type. Now, if you want to construct a chart for multiple variables, then pie chart will be the good option. So here, as you can see, you have 1, 2, 3, 4, 5 options. You can have many number of options, like many different toppings on the pizza. Okay, and disadvantage is that again, it does not reveal the exact values. So if you see the pie chart here, I don't know the frequency number. I cannot count the frequency number here. Whatever you have is the percentile. Do you have the class intervals here? No, I can only see the variable. So that's the main disadvantage of the pie chart. And also you cannot see the pattern so easily. Now you cannot know by observing it that whether it is increasing or decreasing. So that's kind of not seeing the pattern. But only one advantage is that it is easy to understand. I can easily understand the data present in the pie chart. Next is frequency polygon. If you express your data in a line segments, that is nothing but your frequency polygon using class midpoint values. Why I'm saying this is because this is kind of a line segment, right? So if you can see this, you can also say this can be a frequency polygon because it is a line segment. But only difference between that and frequency polygon is your midpoint values. Always frequency polygon is constructed using midpoint values, not the class intervals, not the true values, but midpoint values. Next is this is how the frequency polygon looks like. Again, you can have many number of lines here. So you can compare with multiple variables like this. Okay, you can superimpose the data in frequency polygon. Next is, so whichever we saw till now are the graphs which are most commonly used or which represents the data correctly. Okay, and now we are seeing the graphs which will mislead the conclusion, graphs that deceive. First one is non-zero vertical axis. So what do you mean by that? It means that if you can observe this two graphs, so observe this, your vertical line is starting from 10 percentile. Now, if I have a data between 0 to 10 percentile, where do you plot that? If you're starting from 10 percentile, and if I have a data from 0 to 10 percentile, I cannot plot it anywhere because you're starting from 10. And that is why this graph is leading misleading conclusions, right? And if you observe this graph, it is starting from 0. Now, if I want to plot a data between 0 to 10 percentile, I can easily plot that because I have 0 there. So always start your vertical axis with 0. You cannot have negative percentile, so it is always safe to start your graph with 0 percentile. No matter from where you start your class intervals, always start with 0. So that's one graph. And next is pictographs. It is nothing but your expressing your statistical information using symbols. You are drawing that. That is called as pictographs. So it can mislead you in many ways. For example, see this. So this picture and this picture, when you compare this is like twice of this. Then the percentile should be twice of this. But if you see, here it is 18% and here it is 37%, but it has to be double of 18% according to the picture, which is not. So that's kind of misleading, right? So this are the other examples for of misleading the conclusions, and that is pictographs. It will create a false impressions because you are drawing it. Okay, this is the conclusions, and this is like a summary. So if you have a data set less than 20 values, then it is always better to use a table instead of a graph. Now, one more point. So why are we studying this graph, histogram, and frequency distribution table? Yes, to organize and summarize the big data or even a small data. So we use graphs, histogram, and frequency table to organize and summarize the data, right? Now, my question is, when we have frequency table, why are we moving on to histogram and why are we moving on to other types of graphs? We have frequency table which is very good at summarizing and organizing the data. It is because when you observe frequency table, you cannot detect the pattern. So I have a frequency table now. If I tell me where it is increasing or decreasing, you have to go through each and every value in the table, which is a time consuming task. Now I have a histogram and I tell you where is the increasing point. You can easily tell that by observing the graph. For example, here, if I ask you which is increasing, you can always say that OxyContin is increasing because you can easily see that it has the highest value. When we have a table with a large data set, we cannot tell exactly the highest point because it's a table and you have to go through each and every data, right? And that is why we got the histogram. Now we have histogram, then why are we studying the other graphs? Any guess? Yeah, I could take that answer. And in addition to that, you cannot compare. If you have two or multiple variables, how do you compare the data in histogram? You can only plot only one variable with a frequency. Class interval and frequency is the only thing you can do in histogram. If I have multiple variables, you cannot do that, right? So that is why we have several types of graphs. So all the graphs, all the tables will have its own advantage and disadvantage. So it depends on the survey you are experimenting, or it depends on the situation on which graph you must use for the data. So this is a conclusion part which tells you, which summarizes about all the graphs we studied today. So if you have a data set with 20 values, then it is better to use table instead of a graph. Okay, and next is a graph of data will always focus on the true nature of the data. Like the dot plot and stem plot will always concentrate on the true values. So they are saying that a graph of data will always focus on the true nature of data. Next is do not distort data. When you are constructing a graph, reveal the true nature of the data. Do not hide anything, any other values. If you think that a value will change the pattern of the graph, do not hide that. You have to reveal all the values whichever is there in the survey. And that's about your section 2.3, graphs that enlighten and graphs that deceive. So next is section 2.4, scatterplots, correlation and regression. So we will study about these two today. And regression, I will be teaching this on Tuesday because Monday, I think we have a campus holiday, right? So we will be learning about regression on Tuesday's class. Okay, let's get started. What is a correlation? Correlation is something which exists between two variables when the values of one variable is somehow connected to the other values or the values of other variable. Okay, if one value of one variable is connected somehow to the value of other variable, then we say there is a correlation. So, and if you can draw that correlation in a straight line, we call that as linear correlation. So if you can see this example here, this is a linear correlation example. So here there is a straight line and you are expressing the correlation in a straight line, then we say that this is a linear correlation. If you have something like this, a curve or maybe a zigzag, that is not the straight line. So that is called as nonlinear and it doesn't belong to linear correlation. Okay. Next, what we have is scatterplot. This actually comes under types of graph. So one speciality of this plot, or I can say graph, is that it can compare the multiple variables. Like you have height, weight, and it can have height, weight, gender, education in the x column, and it can also have the same variables in the vertical axis. You will see all these graphs in the lab, or I don't remember which lab chapter it is exactly, but you will be drawing scatterplot, dot plot, stem and leaf, histogram in your labs. Okay, so this scatter plot is used for quantitative data where the first variable will be drawn in the horizontal axis and second variable will be there in the vertical axis. So now here, if you can see, we have a data here with different variables. So arm and waist are the two different variables and we have a data which is correlating them. Now, if you draw a straight line here, you can see that all the data are close to the straight line. And yes, we have a correlation here because it is a straight line, right? So that is why we say there is a correlation which exists. This is another example. And if you can see, you cannot draw a straight line because you already have an irregular shape here. And now we say that there is no correlation, or we say correlation is 0. Okay. This is one more example of having a correlation between the study hours and regent scores. Regent score is nothing but It is divided like in a scale of 0 to 100, and your passing grade will be 65. It is more of your like your grade. Next is linear correlation coefficient, which means you will have some values for the correlation, and those values will be found by the software which you are using in your lab, which is that JMP. So you can find the coefficient values, linear correlation coefficient values, using JMP. Okay, and R is the R is the variable which denotes linear correlation. So it measures the strength of correlation between the variables. So R is the one which measures the strength of linear correlation between the variables. Now, value of linear coefficient R is computed using a formula most often, but in practice we cannot calculate coefficient using formula every time. And that is why we have a software like GMP, which automatically calculates R. And we have a formula, as I said you, we have a formula. So it is like this. So when you input any value there, you will have your output between -1 and 1. No matter what input you give, what values you take, your values of a linear correlation will be between -1 and 1. So you have a straight line here, -1 and 1, and this is your 0. Okay, so what does zero correlation says? It says that there is no correlation existing between the variables. 1 and -1 will say that there is a correlation existing between the variables. Okay, now if I have a value r equal to 0.08, which is somewhere near here, 0.08, which is very close to 0. So I say that there is no correlation. Now I have a value r equal to 0.8, but this is very close to 1, right? So if it is very close to 1, then I say there is a correlation. What happens if we have something like 0.5? Where do you put that value? Well, this is like a midpoint between 0 and 1. It can have a correlation or it could not have a correlation. So by practice, they take that if you have a midpoint value like 0.5, they always consider that there is no correlation at all, because there is no evidence that proves there is a correlation, because it is midpoint which can belong to 0 and can also belong to 1. Most often, it depends on the next digit you have. If it is 0.59, it is somewhere close to 1, because this is approximately equal to 0.6, right? So this is how you decide whether there is a correlation or not. Okay, now let me show you examples. I'm just doing this for your understanding. You don't have to do this. I think you would have done this in your lab 1. Okay, so here, if you go here, you will have a different plots. As I said, we have scatter plot, parallel box plot, and we have, where is stem and leaf? Okay. For example, I have ID and I have weight. I'll click on this and let's see which graph we get. This is like your histogram, but we do not have a vertical bar. So this is more often like a horizontal bar. Let me draw the other one. Okay. So this is your histogram, and if I want stem and leaf, should have, should be having stem and leaf options here. This is your scatter plot, which means data are scattered. So, and that's why we call it as scatter plot. I'm not sure why we don't have a stem and leaf option here, but you must have a stem and leaf option when you draw the histogram. Okay, so here this is the option where we draw the histogram, and this is for different types of plot. For example, if I do like this, I get a very different plot. Okay, so it more often depends on the data, type of data, whether it is categorical or numerical. This is categorical data, and it is somewhat like your scatter plot. So here we have one variable, and here I have different variables. So if I can give you a closer look, and let me draw this one. Now I will click on done. This is like your tabulate form. So more often like your frequency distribution table. Okay, and we can use this data to plot the scatter plot matrix here. So I can give this, and I can give the same variable here. I can have a same variable in x-axis also. Click on OK. This is your scatter plot matrix. Okay, it looks like this. You have a same variables in the x-axis and same variable in a y-axis, and it is comparing multiple variables with each other. So here education level is compared with sex, again education level, smoke, race. So the same variable is compared with different variables. So that's the speciality about scatterplot matrix. Okay, and likewise we have different plots which you will be seeing in your labs. Okay, so that's it about your section 2.3 and 4. So only thing we are left out is about regression. Okay, so that concludes your chapter 2, and we are end of the chapter 2, so we will have a quiz on Tuesday, and it includes everything we studied in chapter 2. Okay, and I am thinking of doing quiz face to face, not in WebEx, because my students are very smart. Oh, I mean, sorry. Yeah, yeah, yeah. Thank you. Thank you for correcting me. Yes, it's on Wednesday. It's on the class hours.